this video, we're going to be talking about chemical reactions of amides. In this video, we will learn how to draw amides formed from amidation, which is a form of condensation reaction between a carboxylic acid and amine. And we will also draw carboxylic acids formed from the acid or base hydrolysis of an amide. So we have seen some of this already, but this is known as nucleophilic acyl substitution. So you have to remember that acyl functional groups are carboxylic acids, our esters, and our amides. So all of these are acyl functional groups. We can interchange all of these different molecules by doing what's known as a nucleophilic acyl substitution. We'll be mostly referring to this as condensation reactions and hydrolysis, but here we go. We can replace this with something else, and then we can interchange these functional groups. So we've already seen how we can interchange a carboxylic acid and an ester by doing condensation with an alcohol and then doing hydrolysis in order to split them back apart. We can also do that with the amide, and so we can also do condensation reactions to form the amide and then hydrolysis to split them. So here is our carboxylic acid, and then now we're going to be doing condensation between our carboxylic acid and an amide. Well, we're going to start with an amine to form an amide. This amine has to have at least one hydrogen on it. That means it has to be a primary or secondary amine. We cannot do this reaction with a tertiary amine because it lacks a hydrogen on there. That H is going to combine with the OH to form water, which you can see over here. And then we merge the other two parts of the molecule. So that NR gets stuck right onto the carbonyl functional group. This process does require heat. Your book will call this amidation, much like they said esterification, but this is a type of condensation reaction. I'm just going to write condensation reaction. Amidation and esterification are subtypes of condensation reactions. Condensation reactions are when you have two organic molecules come together to become one, and a small molecule like water is lost in the process. And so here we show that example happening. If we show this carboxylic acid and this amine reacting together, one thing that can happen is that they form that neutral salt. And so we can see here that that's an acid-base neutralization. And that is a intermediate step there. And then we do our condensation. So we have to heat it in order to get that condensation reaction to happen. Just mixing them together will form the ammonium salt, and then heating it will push it further into that condensation reaction. Tertiary, so this was for primary and secondary amines. And this is tertiary amines. Since tertiary amines lack that hydrogen that I circled earlier, they can only do the acid-base neutralization. And so they can only do that acid-base neutralization. They cannot form amides. Let's predict the products of this amidation reaction. Go ahead and pause the video and try to draw your structure. Unpause the video when you're ready to compare to me. Okay, so let's remember where to cut. We are always cutting on the carbonyl functional group, but on that single bond. So we're going to cut here. And then that's going to look like this. So I can redraw that part of my molecule as is. Now I have to remove one of these H's. And now I stick this end onto there. The nitrogen is directly attached because remember, I have to form an amide functional group. Then I draw whatever else was attached to the nitrogen. So we have to remember that we are forming an amide functional group. And then that also had a CH3 group. So we had to flip that around because the nitrogen had to directly connect to the carbonyl. That carbon does not bond to the carbon, the nitrogen bonds to the carbon. That way we form an amide functional group. Our other product here is water. This is our organic product, and this is our byproduct. But it does say products, and so I am looking for a balanced chemical equation to see that the water is coming off. We can do this reaction. Amides are the least reactive of our acyl functional groups, but it still can be hydrolyzed. And so we can take our water here and do hydrolysis on it. This is showing base hydrolysis. This is acid hydrolysis. My eyeball went later down the screen. And so this is acid hydrolysis. And this is base hydrolysis down here. So you can see that that's an acid and that's a base. So base hydrolysis uses a base, acid hydrolysis uses an acid. That's an acid catalyst, but our water is doing the majority of the work here. So our water is our water scissors. And so we are going to be putting the carboxylic acid back on, and then we will form our amine salt. It's going to be an amine salt because even if we cut this off and made it into an amine, then we are in acid conditions, and since amines are basic, then we are going to be neutralizing them. So that should say ammonium salt. So amines are basic, neutralized by acid. And so then we get our salt out. Our amides, when we do our base hydrolysis, again, we are cutting here in order to reform our carboxylic acid. But since we are in base, our carboxylic acid neutralizes the base. And then we're left with ammonia as a product. This is a gas, and so that floats off out of the reaction. We can also form polymers from our amide functional groups. So you can see this molecule here has an amide, two amines, one on each end. And so we can do a condensation reaction here in order to join them together, and another condensation reaction here to join them together. And so this is polymerization. And then we form different amides. Nylon is a fiber that is commonly used to make pantyhose or like parachute type materials. It's a very common fiber, and this is nylon. It has amide functional groups. Kevlar is also an example of a polymer that is made with these amide functional groups. We talked about how this amide functional group cannot really rotate, and that gives rise to the strong nature of Kevlar, along with strong hydrogen bonding between the different cross-linking layers. And so we have this condensation reaction happening here in order to form our amide functional group. And because of the strong hydrogen bonding interaction between that hydrogen and that O, these fibers are held very strongly together. And that makes Kevlar an extremely strong material used in bulletproof vests. So amides are saving lives. Let's do a practice reaction. Which of the following undergoes acid hydrolysis to yield acetic acid as a product? Go ahead and pause the video and try to work this out. Okay, so what is acetic acid? Acetic acid has a 2-carbon structure. And so acetic acid looks like this. So we are looking for a CH3CO, and so that's an ester. And that's an amide. And I believe the answer is all of these. So all of these have that CH3C feature. And so let me at least box in the O into this. So all of these have that, only one of those here, but all of these have that CH3O. So all of these can undergo hydrolysis.